I'm Mark Hennings. I'm a serial entrepreneur, and I'm super excited to talk to you about fine-tuning today. So let's get started. First of all, let's go over some background information on what fine-tuning is. Let's start with the very beginning, how a foundation model is born. It all begins with pre-training. And we've all heard of this. They take a large amount of text from diverse sources like the internet, and then they train the model. This is a type of unsupervised learning, which means they just give the model the text, it uses an algorithm, and it learns to predict words or tokens in sequence. But then comes instruction tuning. This is how you take a base model that's been pre-trained and turn it into something like ChatGPT, where you can tell it what you want it to do, and it will actually treat what you tell it as instructions instead of just treating it as some text that it needs to predict what would follow that text. After instruction tuning, then you also have this step where they make the model safer. They try to prevent it from giving dangerous, illegal, or unethical output. Instruction tuning and safety tuning are both types of fine tuning, and they're both a type of supervised learning, which means that you give it an input and then you give it an output that you actually want it to give back from the input. So it's learning from your input and output pairs. And they're very, very important steps because raw large language model behavior is unpredictable before it's fine-tuned. In this example with GPT-3, you say how to bake a cake. And it kind of does what we are used to now from using tools like ChatGPT. But if you go back to the base model that hasn't been fine-tuned and you give it the same input, it does not treat it as I need to give you a recipe. It just goes off in a strange direction. And that's what can happen before you train a model to be instructed. So let's dig in a little deeper there. And let's think about what we're actually giving a model and what we expect it to do. If I tell a model ABC, what do I want from that? Do I want it to autocomplete it? Do I want it to define the first three letters ABC as this is part of the English alphabet? Do I want to translate it into another language, transform it into uppercase? Or do I want it to ask me, what are you thinking? Why are you giving me these three letters? Like ChatGPT. Fine-tuning allows us to show the large language model how we want it to apply knowledge. It has all this knowledge from the pre-training stage, and fine-tuning is what allows us to kind of harness that and direct it to a particular task. Some of its characteristics include it's a type of supervised learning that we already talked about, which means it needs input and output examples to know what to do. It's a type of transfer learning, which means we take an existing model and then we can fine-tune that. We can fine-tune a model in multiple steps. You can fine-tune a model that's already been fine-tuned. It's much less computationally intensive than pre-training. Of course, this depends on the size of your data set, but in general, it's very expensive to pre-train a model, and fine-tuning is flexible. You can take that base model and you can fine-tune it. You can fine-tune it again. You can try different things, and it's not going to take you months or cost millions of dollars. Fine-tuning also limits the scope of what a model will do. It increases the predictability of the model behavior. Instead of it going off in some random direction, it's going to follow what your training examples show it to do. So if you're steering the model to do one particular thing, that also makes it bad at doing other things. So it's important to decide exactly what you need your model to do and fine-tune a model for that. And then since fine-tuning is very easy to do and inexpensive, you can fine-tune different models for different tasks. You don't have to create one super model that can do everything. That's more like what these chat-based models we already have can do and why they're so great with prompt engineering. Fine-tuning allows us to really hone in on a particular use case and get a model that does that exact thing super well. A few misconceptions that are floating out there include that fine-tuning teaches the model facts. This is just not true. Models may repeat incidentally things that were in the training data set, but it's more like them imitating the tone or the style or the formatting of the training data. And it's not a guaranteed behavior by any means. A better way to handle facts is to provide it in your prompt and use a technique like retrieval augmented generation to make sure that you're giving the model the facts that it needs to generate some kind of output based on. Because large language models are really good at handling facts inside the context window, but not so good at retrieving particular or discrete facts from their training data. That's just not how they're designed to work. Another misconception is that you need this really massive, impossible sized data set to fine-tune a large language model. And that comes from the machine learning days, maybe 5-10 years ago, when it was true that if you wanted to do fine-tuning, you needed a really large data set. But because large language models are pre-trained on so much information, they don't need a lot of examples to start doing a pretty good job. One way to think about this is as an extension to few-shot learning. So if you can provide, say, 10 examples inside your prompt, with fine-tuning, you can have a training data set with an unlimited number of examples. And instead of being limited by the length of your prompt, you can move that into your training data set and you can train the model. And because it will have more examples of the type of inputs and outputs that you expect or that it might encounter, it can do an overall better job. Okay, so we mentioned retrieval augmented generation. And that's a technique that uses semantic search to find relevant information to include in the prompt. And it's great for improving truthfulness and accuracy of outputs by providing facts in the context window. And fine-tuning works really well with it. Fine-tuning is not so much for teaching facts. Retrieval augmented generation is great for getting the information and the facts that you need. So you can use fine-tuning to kind of steer the formatting of what you want out of the model to optimize its performance. And then you can use retrieval augmented generation or other techniques to get the information in your prompt to make sure you're getting a really high quality result. They work great together. Okay, so when should we actually fine-tune a model? What is it good for? Well, let's start with a little definition here. So fine-tuning, the way we're going to talk about it, we're not going to do safety tuning or instruction tuning. We're going to train a foundation model for a specialized task. And examples of these tasks can include writing any kind of content, emails, blogs, product descriptions, scrubbing fake emails from a list, extracting or normalizing data, translating, paraphrasing, rewriting, qualifying sales leads, ranking priority of support issues, detecting fraud, flagging inappropriate content. Very common tasks in businesses. And traditional programming is really bad at them, but large language models are great at them, especially when they've been fine-tuned. So hold on. All those examples I just gave you, you can definitely use prompt engineering, right? Of course. So why should I fine-tune a model? Well, because it's awesome. Fine-tuned models are faster and cheaper because you can train a smaller model to match the quality. They reduce the size of your prompts, allowing for longer completions. Training examples allow you to cover edge cases and collaborate better as a team. And fine-tuned models, because they narrow the scope of what your model will do, are naturally resistant to prompt injection attacks. So how much faster are they really? Well, if you just compare GPT-4 versus GPT 3.5, and you look at the average response time for 10 tokens, the difference is 2 seconds to 730 milliseconds, which is a 3x difference in speed, which I don't need to tell some of you UX experts is a big deal. Now let's talk about cost. For 1 million requests on GPT-4 versus GPT 3.5 fine-tuned, you are looking at an 89% savings. Over the long run, especially at scale, that is a big difference. Part of this is because you're using a smaller model, and part of it is because your prompts also get shorter too. With a typical engineered prompt, it might say something like, write a blog post on the topic and use this kind of tone and style. It has some adjectives. It tells you what to do, what not to do. For a fine-tuned model, you just need the thing that's different, the unique information for that particular task that you're asking it to do that's different from all the other tasks. And in this case, the only difference between this prompt, if you had it on one blog post and another blog post, would be the topic. And it's 90% shorter. This actually allows us to write longer form content because our prompt isn't soaking up all of our tokens in the context window. Another claim I made is that fine-tuned models are better for working as a team. And I want you to think about how this scales. If you have one epic prompt that everybody's supposed to collaborate on, it's like having one file in your GitHub repo, and your whole code base is this one file. And if somebody wants to make a change, they have to make sure nobody else changed the same text, or they might bump into each other. With fine-tuned models, your team can all work on different training examples, which is this layer that then feeds into the fine-tuned model. So you're not going to run into each other as much, and you can actually add functionality or handle edge cases simply by adding or modifying different examples. So the main point of all this is if you can get equal or better output, why wouldn't you fine-tune a model? And the answer is probably just that fine-tuning looks really hard. It looks like a dev job. All the guides and tutorials online talk about spinning up GPU servers for training and inference, formatting training data with ad hoc Python scripts, configuring parameters and making API calls. It looks like a lot of work. It looks like you need a developer to do that. And what I've spent the last 10 months working on at Entry Point is answering the question, why can't all of that be automated with a convenient user interface? And it turns out that is totally possible. And it changes the game. Because if you don't need developers to do your fine-tuning, well, then you can start with prompt engineering. You can create a prototype and validate the concept. Then you can create this really awesome, optimized, fine-tuned model. You can evaluate it to make sure it actually performs equal to or better than your prompt engineered version. And you can build the data set using prompt engineering tools as well. Then you move your model into production, and you can capture feedback and log examples and take those examples and feed the best ones or the most useful ones back into your fine-tuning data set. So it becomes this process of continuous improvement. And where we need the developers is moving that model into production. And it opens up a huge opportunity for other people to be prompt engineers and fine-tuning experts and do all of that without writing a single line of code. And the bar is lower than most people think to fine-tune a model. Like we talked about earlier, as an extension to few-shot learning, if you can get 20 examples of what you want a fine-tuned model to do, you can fine-tune a model. And Entry Point offers the modern tooling to make this easy. Let's dive into a demo and see what Entry Point can actually do and how it can help you become a fine-tuning master. So here I am in Entry Point, and I have this press release writer project. Let me show you around and show you how it works. When you import a CSV into Entry Point, it creates a field for each column. And you can name these, give them this reference, specify whether they belong in the prompt or completion. And we have this flowchart view that shows you what your inputs are and then what your outputs are. But there's also formatting that goes around that. For example, do you want to label some of these things in your prompt and completion? Well, we have templates for that. So here's a ChatGPT 3.5 Turbo chat template, which has the input. And I use this field for the facts. So if I want to include my facts right here, I just insert it and I have a label for the facts. Because with a small data set, labels can help semantically inform the model of what it's looking at. With the output, we just have the press release. And then there's this third part, which is the system prompt. And if you've already used ChatGPT a lot through the web interface, you're probably familiar with this because you can insert some custom things into the system prompt or your user preferences that will steer the model in the direction you want every time you're conversing with it. And it's very much the same here. But what it effectively does is allows us to use instructions with our fine-tuning data set. It's basically a hybrid between fine-tuning and prompt engineering, where we have a small fine-tuning data set. Here I only have 20 examples of press releases for this press release writer project. So I decided to include some instructions in the system prompt. In particular, I was getting some outputs where it would switch into first-person perspective, and I know for press releases that you use third-person. So as a quick fix, instead of adding more training examples or going through my whole data set, I just adjusted the system prompt. You may be familiar with this syntax, actually, these double curly brackets. If you've ever written a marketing email and tried to insert somebody's first name or last name into it, you know that these are basically used for templates, and they allow you to inject specific information into your template. It's called the handlebars templating language. So it's a very useful way to both have structured data instead of blobs of text, and then also format it in the way you want for your prompt and completion and try different things and see what works best. After we have our fields and our templates, we can look at our examples. So the examples are when you take the actual data and put it into your template. I actually got these press releases by going online, Googling best press releases, and then finding ones that looked good. However, the problem was that these best press releases didn't have any type of input data associated with them. So what I did is I took the final press releases and then I pasted them into ChatGPT along with a prompt asking for it to create a list of facts from that press release that would be required for a professional writer to actually produce it. So then my list of facts look like this. I have one on each line. So there's a line break between them just to separate them and keep it nice and organized. We have token counts, so you make sure you stay within the context window. And just to reiterate, we only have 20 examples of these press releases. It took me about an hour to produce this data set, which, to get a working model that's going to automate press releases for me forever into the future, is kind of cool. If I want to add examples, I can import more from a CSV, or I can manually add them just like this. Entry Point also has a tool to help you generate examples, so you don't have to write all of these manually. Once you have a few, you can go into our data synthesis tool and you can start generating examples using AI. So here's one that I just generated. It has a list of facts and a press release completion. I can go ahead and add that to my data set if I want, or I can clear it. I can go into my settings. I can actually tweak a bunch of settings, choose what model I want to use with this. Here I need one that has a larger context window because I'm working with kind of long form content. And I can use the alignment text field to actually specify what topic I want the press releases to be on, or any kind of way that I want to steer the examples. But if I just hit start, it's going to take a little bit and it's going to start working on examples for me. All right, here we've synthesized an example and we can see that there are some made up facts and it looks like a press release. I'd have to, of course, read through this to actually decide if it was high enough quality to add to my training data set. But that's still so much faster than having to write examples from scratch. Once I have an example data set, then I can go into my fine tunes. I can start a new one just by pressing the add button. I can select my model. We count your tokens and estimate your cost for you. This is going to be a whole $1. So hold on tight. And then there's other parameters you can define, or you can just leave them alone. I find that the default ones work pretty well. And then you press start. I also have some models that have already been tuned. So let's go into one here. I can see exactly what template it was trained on. And then I can go into the Entry Point playground here. So for my demo, I have a list of facts that I pretty much scraped from the Prompt Engineering Rocks website. And we're going to generate a press release on the Prompt Engineering Conference. So down here, I can select my model. And I can choose the temperature and other important parameters. Press Get Completion. All right, so it wrote a press release here. It took my list of facts and it turned it into the formatting that you would expect for a press release. Looks cool. I've actually found a really fun workflow for doing this kind of long-form content generation using fine-tuned models, where I input the list of facts and then I read the press release, or let's be honest, I skim it, and then I get ideas from it, like quotes that I could add, for example, or if I want to get real contact information at the bottom, and I put that back into my list of facts, and then I generate it again. So it becomes this iterative process of generating content that is much faster than trying to just sit down and write it myself, especially if I don't know how to write a press release. We can also get really crazy and increase the temperature and see if it gets more creative. Temperature is a setting that affects the probability of it selecting different tokens. If you set temperature to 0, then the model is always going to select the most likely token. It actually makes it completely deterministic. So if you've heard large language models aren't deterministic, that's not entirely true. If temperature is 0 when you're doing inference, it's deterministic. If you set temperature to higher, then it's going to be selecting tokens that are not the most likely token, which can have this effect of making it seem more creative. And that's typically what it's used for, is more creative, more diverse types of outputs, but it also makes it less predictable. Definitely a really useful setting to play around with when you have a fine-tuned model. In this case, it made it a lot longer. So that's a really quick overview of Entry Point. I want to make it really easy for anybody to create custom AI models without code. We have a free forever plan where you get 50 free training examples, so you can get in, you can play around, you can see how it works, and you can start fine-tuning right now, within minutes, if you want to. Thanks so much for watching this video. It was awesome to get to talk to you today, and I look forward to your questions. Cheers.